So I've covered a little bit of this already, so I'm just going to move to the slides with pictures. So this was actually the before and after of what we built on Endeavor. So on the left-hand side, so this was our original purely physically based network. And again, like I'm not like putting this up so I as like a dig or anything. The point is that, the purely physical networks are in themselves, the configuration is very simple. But the issue is that the ongoing maintenance is eventually it builds up, you know, it becomes the death of a thousand cuts. And the other issue is that, because if you're dealing with something that's purely physical, like there's no ability to just like copy and paste it over onto another ship. So if you look at like the overall life cycle complexity fleet-wide of doing everything purely physically, it's a straight line. Every single project is its own thing, and everything involves cabling, and especially when you go between different areas on board, it just creates this massive difficulty curve. So going over to VLANs and VDOMs, the cabling itself is, we don't have all these individual um, isolated network connections. The idea is that everything is organized into a tree of we've got the Fortigates that are managing traffic flows between networks. We've got our pair of core switches in between the Fortigates and the supermicro UHDAS machines. So we've got and then yeah, so those Cisco switches there with the yellow labels, that's kind of the middle layer of the tree that's connecting everything together. And all the onboard network switches and Wi-Fi access points and the physical connection to the 5G modem, to our Marlink service, to the Fleet Express deck unit, all of that stuff comes into the core switches. And as you can see there, I mean, there's two. The bottom one doesn't have anything plugged in, but the idea is that this is serving as a warm spare. So if the top one fails, the cables can be repatched. And this is a case where, you know, even though we added a little bit more configuration side complexity, we were able to take out a lot of the just physical, like weight of the infrastructure. So one of the things that we've started to touch on a bit too is if we look at like the triangle of these, the VLANs, VDOMs, VPNs, these are all things that are directly involved in traffic flow. Every one of these is something where you go to Google, you're touching all of these three virtualized components. But something we've talked a little bit about how different institutions may have, they may want to tunnel it back to the host institution, or they may just take internet at the hub, or they may have different usage policies. That's where we get into this level of what are called administrative domains. And these operate basically one level above the um, VDOMs and VLANs and VPNs. And the idea here is that we have, we could say, okay, here's, this ship at this host institution, and, their policies may be slightly different. They can inherit certain global policies and the config necessary to make the reference architecture work. But on the other hand, if, UH wants to operate differently from URI, wants to have different like access policies and so forth compared to, I don't know, UDEL or UW or any of the other institutions here, that's the purpose of having this higher level container. And this is what it starts to look like. Um, we talked about how there's 5 individual Pokeballs on the network diagram. So in this case, we've got the shipboard LAN and OT instances. We've got the shipboard WAN component. Those are all things that physically VDOMs on the shipboard infrastructure. And then we've got our Endeavor slice of the hub. And these are actually the templates that we applied. The idea being here is that, okay, here's this generic, you can see on the left, here's the actual template, and then here's the specific variables that plug in as appropriate for the ship. and then we apply it to the appropriate devices, and then it's, done. So, there's certainly, you look at the overall, like combination of nested abstraction layers, it is a lot. This, compared to like say setting up the peplink, um, there's a lot more going on here. Um, I counted at least like three separate layers where we're saying, okay, there's reality, which is there's like a pair of FortiGates in front of you. And then there's all the, the interface level virtualizations, which is this Ethernet port carries 10 different onboard networks. And this, internet connection on 5G goes to this hub site and this hub site. And then there's the even deeper layer where we're saying, well, now, some of these things are bound to a certain router, and then some of them are bound to a different one. And then the final level that we, practically deal with is like the what I call device manifest level, which is your ADOM, which is like all of this virtualization fits into here's this ship. But the part where this is where the inception happens, and we can say, oh, okay, instead of having to, this is how we facilitate being able to move things, copy things between different ships. So this is this sort of basic network services are, back like from going back to the more practical like day-to-day stuff and from the like, just absurd, like reality bending what is this device and, like collapsed universes that fit in. Um, DHCP, DNS, these are things that as we build out this data collection spreadsheet, the idea here is that all of the critical things that you need to basically give you usable internet can be run on a redundant pair of devices. And instead of having a bunch of random, different things, all of this can be centralized, managed in the same system. But on the other hand, we've got high quality rack equipment and we've also got a managed, primary, secondary unit. A little bit about username capture and inventory. This is something where we talked a little bit about the, making sure that we include the LAN side as well as the WAN. It is, if we look at the logistics of deploying the system, the the best thing would be to have the LAN networks as well as the WAN side tied in, managed by the FortiGate. And the reason for that really is I think the biggest thing that it gives you is metadata capture. Keep in mind, like things like, usernames and device inventory, like that's not a standard part of like IP as a protocol. There's no field for like, oh, this is my username and this is like what my real name is. So anytime you're looking to capture things like username and device information, like, that metadata is not necessarily easily transferable between systems. So while it is possible to do the system, it doesn't have to do all of the onboard networking. If if there's an existing Cisco router that's managing the different LANs on board, and this can be deployed so that it only does the WAN side from the template, but it really is a lot easier to operate if it's doing everything. And that's where, especially for if we look at, host names are something where those are technically easier to capture, but the issue you run into there is like my phone. Like my phone does not say Rachel Simon's iPhone. It's, Burgermeister. So, trying to figure out who that is not the easiest thing in the world. So there are a couple approaches that we're testing. Between the two, I would recommend the captive portal. That's kind of the default that we're already using. It's, it's how hotels operate. And it really helps you not have a bunch of nightmares with like, somebody's host institution. Like if I have a URI laptop, so if URI's got all this security client software for URI's network, well, if I try and bring it on somebody else's managed network, that's probably going to cause some difficulties. And that's why I think operating kind of like a hotel is, hotels are usually pretty successful about doing this. So I think that's a good model to emulate. And of course, like we talked about a little bit earlier, if somebody's really just absolutely hogging the internet, just temp ban it and see who complains. And this is a little bit about so this is some of like what this device metadata capture looks like. And the reason we're able to get this in as well as some of the graphs that Ken showed you is because we have the FortiGates doing the LAN side as well as the WAN. So the FortiGate's aware of, oh, this device is, a Windows computer with the hostname Midson, and it's talking to the internet, and it's specifically using, oh, this is going over the KU or the Marlink KU VSAT. So this with with a little bit so far I've talked about like how these different things fit together, as well as the LAN side and how we get metadata, as well as how we get clients online, but also how we can get some metadata from them. And now what we'll do is we'll change gears and we'll focus on the internet side. So this you might have heard the term SD-WAN. SD-WAN is basically, I mean, it's really a marketing term. It stands for software-defined WAN, which I think is a little bit ridiculous because everything in software is software-defined, unless you have like an IBM System 3360 that has physical hardware toggle switches, like an any file is software-defined. But basically, really what it's doing is what this is providing is saying, okay, so instead of configuring these like really hard-coded defined rules about, okay, I want to go, to path, let's say the VSAT versus the shore link. Um, the goal here is that you can say, okay, so I want to have rules that are aware of like what an application is, what the source is, and I want to really tell the system preferences. So, generally speaking, we want to prefer for our default behaviors, we want to just prefer the lowest latency interface. Um, the that's gonna we want to use the 5G for as long as possible. We get pretty good 5G even in coastal areas, so we want to try and stay that on that connection as long as we can until it starts to get glitchy and until it starts to drop out. At that point, then we want to use something like Starlink. And our default policy for the ship is, okay, when we have to fail back to the C-Link KU or the Fleet Express, obviously we want to do that. But, we want to have other options first that are lower latency. And what this SD-WAN is doing is we have like all these different paths available, talking about going to the hub sites. In the event that the hub sites go down, then the last thing we would want to do is have a ship that has 5 different working local internet connections and can't get online because the 2 hub sites are down. So, as you can see here, we talk about the different types of paths. So the overlay is when you're going back to the hub, and the underlay is just if you go right out on the VSAT modem or the 5G modem or what have you. And, all of this really comes down to um, trade-offs. The advantage of going through the hub is that there are, the site needs to work. But the features you gain are static IP addresses and better control over downloading. And we've talked a little bit, we've actually talked a lot about having the ship having static IP addresses and US-based IP addresses. So when we were planning the install on Endeavor, one of the biggest concerns that we had from the crew, from everyone on board, was the fact that, you know, our Marlink service and especially our Fleet Express give us European IPs by default. So you go to like weather.com or Google or literally everything, like Google Docs would show up in Dutch, and there was no easy way for us to change it. So the reason why we keep coming back to that point is because like that was one of the biggest day-to-day problems that we had to face when we were working on board. And it was an issue that we were able to resolve successfully. So, yeah, we get into detail about the security advantages of tunneling, but there's also a lot of just day-to-day operational advantages that come as well. So what this looks like is this is the case where, so this is actually how the system is selecting an interface. So you can see we didn't set the aliases during install, but so this is hub one, and we have a couple different pathways there. We can go via the cell modem, we can go via main VSAT, which is our C-Link KU 4x4, and then we have the backup VSAT, which is our Fleet Express, it's about 2x2. And in this case, the FortiGate, it's constantly running these health checks. This is kind of the same idea as the peppling. So it's constantly running health checks. We have some rules so that, as you can see here, the hub one overlay via the cellular modem is what's actively selected. But if that was to start getting glitchy or finicky, or if it was to fail entirely, then it would start going down the list. And the backup option, the list is kind of long, so it's cut off here. But all of these cellular main VSAT, backup VSAT, in the event that the two hub sites are down or otherwise not connectable, you can always get online via local internet. And this is something how this works is that each WAN interface, so you've got like your local internet pathway, but then you actually have these hub tunnels that are bound to that specific internet connection. And that gets me to the sort of the final big part of the configuration is firewall objects and rules. So a lot of the other parts of the system, all the virtualization, all the VDOMs, all of these, the whole idea of these and the bottom of the Pokeball diagram is that all of this is basically set up so that the policy statements that we interact with and especially have to troubleshoot, we want to have all this set up so that our defaults make sense and we don't have a million different. In the event that we do need to have, everyone is going to have some number of rules, but we want to bundle rules together. The idea of creating objects instead of just punching in IP addresses is you could say, oh, like the policy for Bonnie's winch application. So the idea there is that we want that to be accessible by most of the ship. So we have a couple different objects that are the source there. So instead of having to duplicate that rule a bunch of different times for different sources, we can say, oh, well, this rule applies to this one object on the destination side, but there might be 10 or 15 different objects representing different components of the ship's network, but they can all be condensed down into a single place. And this is a little bit about, like there's an any is an option. Like we have our public onboard web server. That's something where, we could just say like anything on board can get to this. So the final part here is about traffic flow and, really building some rules. We've definitely spent a lot of time talking about configuration, but, the configuration is the hill that we have to climb up so that we can make simple, default, and effective policy statements. And there are really, if we look at, where those come up, there's really three places where they are applied. The three on the there's three major tools. So on the onboard side, there might be a lot of different devices, but it's a pretty definitive list. On board, we're not worried about bandwidth limits or like generally speaking, we're not going to have high packet loss. If we do, it's usually because the cable's broken, not rain or anything ridiculous like that. So if we look at the three components being firewall rules, SD-WAN, and traffic shaping, on board in the LAN and OTN VDOMs, this is where, we're just focused on firewall rules there. Once we get onto the WAN side, we have a combination of firewall rules and SD-WAN and traffic shaping. And, these are parts that complement each other. So firewall rules are, explicit blocks. They're applied in an absolute fashion. You can block certain, you can say here, source destination IP address, or alternatively, you can also block applications. Like we talked a little bit about banning gambling, online gambling. There's certainly bigger picture policy implications there, but on the other hand, this is more about the technical part of how would you do that. Firewall rules, is it allowed to get there at all? SD-WAN is how should it get there? Which path should it take based upon current conditions and the behavior that's been defined? And then the traffic shaping is telling us how important is it. Examples of how we could use firewall rules, some of the immediate things that come up are like blocking Windows Update. But an example of how, well-structured rules can pay off. So we talked a little bit about how, in the event of an emergency, okay, so, we always want to have the bridge getting internet access. But on the other hand, in the event of an emergency, it might be, or especially telemedicine, it would be appropriate to drop connectivity for most of the vessel. So this is a case where, most people are using defaults that can be disabled if needed. On the SD-WAN side, this is the case where we have these rules set up so that we're preferring the most optimal pathway. And the final thing will be the traffic shaping. And we've already touched a little bit on it, and I know we're getting towards the end, so I'll just leave this up on the screen for reference. And we can get into more detail offline. And I think that's it for the slideshow.
Okay. Does anyone have any questions for Rachel? It's after lunch. I think that's the problem. Thank you so much, Rachel. Are you going to be hanging out on the forums and stuff this week for questions?
Yeah. So if I will be keeping an eye on Huva. I don't get back into home until the 5th, but certainly can share about I'm on Huva, email, phone, all great ways to get in touch with me.
Andy, I just want to say, so it's sailing on Endeavor with this. It worked really well after Rachel did all this setup. We basically was trouble free. Didn't take any time from the tech to deal with this.
That's good. Could you hear that, Rachel?
I did. Thanks. It was a little bit tough, but I think the hearing that bit of praise, my brain worked overtime to make sure I could, get that little bit of ego boost.
Okay, well, thank you, Rachel. Appreciate it.
All right, thanks. Yeah, any more questions, hit me up on Huva, and I'll let you guys enjoy more pillow basalt or whatever these things are.
Awesome. So we have one more presentation today. But again, I'm going to give you guys a quick 10 minutes to stretch your legs. So we'll start again on 5 after the hour. So far, we're only running 5 minutes late for the whole day. So you guys are fantastic. See you in 10.
How did I get here?
I'm glad you did.